There are two special cases I want you to be aware of. In both of them, what happens is not just one variable, but both variables end up being eliminated. That happens sometimes. When that does happen, you're going to be left with an equation that's just numbers, and sometimes that equation is false. False equations look like this: 0 equals 3. Well, no, it doesn't. 0 is not equal to 3. Or 7 equals -2. Well, no, it doesn't. Those are not equal to each other. Those are false equations. If that happens, it just means your system has no solution. There is no ordered pair that makes both equations true at the same time. If you end up eliminating both variables and are left with a true equation, something like 0 equals 0, that is true. Or -3 equals -3, that is true. Then what that means is that there's not just one solution to your system, there are lots of them. Infinitely many, as a matter of fact. Any ordered pair that makes the top equation true will also make the bottom equation true. Let's see how this shows up in our work by looking at these two examples. In the first case, okay, they're both already in standard form. We've got a set of opposites. We're ready to add things together. 3x's plus -3x's, 0x's. -4y plus 4y, ooh, that's also 0y's. So 0 plus 0, there's just 0 on that side of the equation. Over here, 2 plus 8, well, that's 10. And 0 is not equal to 10. This is false. So the variables got eliminated. False statement left behind. This system has no solution. There is no ordered pair that will make both equations true at the same time. Let's take a look at case number 2. Top equation already in standard form. Bottom one isn't. Okay, so I'm going to leave the top equation alone. But for the bottom one, let's add these two y's over to the left-hand side of the equation. That's going to give me 5x's plus 2y's equals -7. Now we're ready to add things together. Those are opposite, go to 0. Those are opposite, add to 0. And 7 plus -7, that also goes to 0. Ooh, this is true. What it means is basically the equations are the same. That's why when you subtract them, you get zeros everywhere. So any ordered pair that makes the top equation true will also make the bottom equation true. I'm going to make a note of that by saying, hey, this system has infinitely, that's an M, many solutions. And I can leave it at that. So again, the biggie. Here's the summary. If both variables are eliminated and what's left is false, the system has no solution. If both variables eliminate and what's left is true, then the equations are the same thing, meaning there are going to be infinitely many solutions.